Hey guys, welcome back to another video. In this video, we're actually going to be building the model for the neural network that we were working on. So in the last video, we pre-processed the data set. So I'm just gonna have a quick recap of what we did in the last video. We imported a few libraries. Then we imported the data set. Then we split our data set. Then we fixed in a variable that has all of our our types of clothing names, and then we pre-process our data set so all of them can be um, grayscale image basically. So yeah, now we're actually going to build our model and train our model. So first, I'm going to create a variable that's called model basically, and keras dot sequential. Right, so sequential. So I'm just gonna bring it in, and now we're just gonna create our model. So first I'm gonna bring in keras and then layers, and then now we're gonna create a flattened flattened layer that I'll explain what flattened means. So just follow along. So input shape, and I'm going to set that equal to 28 by 28 pixels, of course. So now, what does this code do? So let me get my drawing tool. So what this part of code does is that basically, guys, the flattened data, flattened layer, what it does. So this, first of all, this code that we just wrote is for the input layer. Oh wow, handwriting is sloppy. Input, right? So I'm just gonna erase those. So we're gonna create. So that's the input layer, right? So that's gonna have our data. So the flattened what the flattened layer does is that it transforms the format of the images. So it converts them or transforms them into a two-dimensional arrays. So it's gonna have only so it would look something like this basically. 0, 255, 0, 236, stuff like that. So it's going to convert them into two-dimensional arrays, and that's why. And we fixed some parameters inside the flattened dataset, as you guys can see. That's all we did. That off. Okay, so now let's go to the code. Now we're gonna make the hidden layer, of course. Keras dot layers dot dense. So what this dense layer does is that it just means it's fully connected. So it's gonna have 128 neurons, and I'm gonna set the activation key. So activation to equal to this. So this is just a basic activation function, so we can actually have an output. And now finally, I'm gonna have a layer, another dense or fully connected layer. It's gonna have 10 neurons. This is just the output basically. So boom, we made our we builded our model. So there's a, oh my gosh, oh wow, it's a typo. As you guys can see. So boom. So yes, that's a typo, guys. So now we're gonna compile our model. So model dot compile, and I'm gonna set an optimizer. Wait, I'm gonna set an optimizer that's equal to Adam. Okay, good. And I'm gonna set a loss function. Wait, no, not a function. To sparse categorical cross-entropy. Pretty sure that's how you pronounce it. So I'm gonna bring it in. It's inside Keras. Keras is an amazing machine learning, no, not machine, deep learning library. No, TensorFlow and Keras are like one of the most best libraries for deep learning. So sparse categorical cross entropy. Boom. And now I'm gonna put a parentheses. Inside these parentheses, I'm gonna put from. Wow, it's too large, I guess. I'm gonna do that. Okay, better. From logits, logits equal to true. And now set the loss function. Now finally, what we have to do is set a metric. So I'm just gonna put accuracy. Metrics. Set that equal to accuracy. Accuracy. Boom. So let me. Okay, good. Now I'm just gonna shift enter. Yes, boom. We have all of our. So first we build our model, then we compiled our model. The last thing that we have to do is train our model, and after that we have to test our model, basically. So first, I mean, this training part is very easy. First, we have to just bring in our model. Now we have to use our fit function. This fit function is used a lot. You use that in machine learning too when you like put in data. So I'm gonna have parentheses. Now I'm gonna feed it the train images as well as the train labels. That's what. So now we feed it some data. Uh, now we have to fix another parameter that's called epochs. So epoch. I believe that's how you. But yeah, this is this. Okay, so I'm gonna do. So what does this epoch mean? So epoch just means like how many times like you want your model to like train on, or stuff like that. How many times you want how many times you like want your neural network to see the same data. Basically, I'm gonna set that equal to 10, and yeah, it's as simple as that. And if I press Shift Enter, boom. As you guys can see, I'm gonna zoom out. It's actually training right there. See that? See guys? So finished one epoch. Now it's done with the second one. Now it's done with the third one. Almost. Come on. So as you guys can see, why can I scroll down? So as you guys can see in the accuracy for the first one, it was 82%, and then it went up to 86%. That's good. I mean, it's making progress. So it's on the seventh epoch, and it makes progress every epoch. But you should always, and you should like always make sure that you don't add too much epochs, or you will experience some problems basically. So come on. Okay. Boom. It's all of the epochs are done. So our model is done training. Now it's time to evaluate the accuracy. So the test accuracy. And this is like the last thing that we're gonna do. So like to see how well it did on the test dataset. So now I'm gonna create. So I'm bringing our model. I'm gonna evaluate it. Evaluate. So now we're gonna evaluate it using our test images. Test images. Image. So come on, image. Oh, sloppy typer. So now we're also gonna bring in the test labels as well. Labels. Boom. It's gonna fix in another parameter. Two. And yeah. And now we're gonna print our the test accuracy basically. So I'm gonna do that here. So print. So before actually doing that, I'm gonna like create. So I'm gonna put this piece of code inside a variable. Test loss, comma, test accuracy. Boom. Now I can just do. Come on. Now I can just do test accuracy, and we have to actually print our test accuracy, how well model neural network did its data that has never seen before. Now if I do shift enter, oh wow, it has 88% accuracy. That's very good. Yeah, it's very good. That's how well it did on the test data. So now we're gonna like actually make more kind of predictions. So first, for this, I'm just gonna do probability. So I'm gonna do so I'm gonna create a variable called prediction or something. Prediction prob. Prob just stands for probability. So I'm just gonna bring in TensorFlow and keras dot sequential. The sequential function, and here gonna put in model, and we're also gonna put in the tf dot keras dot layers dot soft max. Okay, so I'm gonna zoom out a bit so you guys can see. Soft max, and I'm gonna do that. Boom. We're also gonna do predictions, and I'm gonna set that equal to our prediction probability variable. So, oh wait, oh, what happened? Oh wow, guys, there's two cursors. Okay, that's weird. Okay, so, oh well, battery slow. So prob, and then you're gonna do that, and model dot predict. I'm just gonna do a space there. Predict. Now we're gonna give it the. Now we're gonna give it a test image. Here. Test images. Boom. We're done. It's that piece of code, and we have an error. Wow. Oh wait, so that's the error. Okay, I'll fix that error in a sec. So I just changed the model, like the variable name. I just changed it to prob model. So after you do that, we're just gonna give in a few code basically. So now we're gonna I'm just gonna give so this piece of code. I'm gonna print it out. So this is like one of the things. So so this is like the 0th image, and as you guys can see, the what do you call it? The neural network knew that it was a 97% ankle boot, but and only 3% this 7th image or something, in 3% something else basically. So so our models is doing incredible. So yeah, this is like the end of the video, and make sure to subscribe to my YouTube channel, and for more videos, and yeah, remember to like this video as well, and yeah, remember to like leave a comment or like ideas that I can like post videos on about basically. And yeah, if you have like any questions, you can just post them out, or yeah, anything like that. So yeah, see you guys later. And one thing, so this code is from like the TensorFlow website. I'll be providing the link to the TensorFlow website in the description. So yeah, but check that out for more detailed, and like in like a, what do you call it, in a website sort of way. This is very detailed. The video that I just made is very detailed, but if you want something like similar to that, you can just go check the website out. I'll be providing a link to the description. So yes, see you guys later on Shriven the Prodigy. Bye guys. Oh wow, that didn't work out. Oh wow, didn't work out.